PowerPoint we got. But we've talked about arrays and we've talked about array lists. Array lists aren't even in this chapter, so that's pretty cool. But looking at our homework, we did some single dimensional arrays, we did double dimensional arrays. The only reason I look at y'all when y'all are talking, I don't really care, but there's only 4 people in here, and if y'all are talking, that means half the class isn't listening, so no biggie. So let's talk about array lists a little bit more. I want to broach the concept of stacks and queues. And I guess I'll draw on the board, which will be real boring for the people watching the video. The idea behind a stack and the idea behind a queue. A stack works like this. You have a stack of dinner plates. It's called pushing. We push another plate onto the stack. We push another plate on the stack. That's plate A, B, and C. Now we're ready to start serving food. We give somebody a plate. They get plate C. We give somebody else a plate. They get plate B. So now these are gone. Then we get some new plates. So we go ahead and start stacking them up. D, E. 2 more customers walk up. So we grab that plate. E. This is called popping. We've popped that item off the stack. They need a plate. Now we're left with that one. 5th customer comes in. We pop that one off the stack. The stack is now empty. We have 8 plates. The order is kind of weird. C, B, E, D. Was that supposed to be an A? Yeah, that was supposed to be an A. All right. So what really happened is that a stack is first in, last out. The first thing we put on the stack is the last one that came out. And then as we put more items on it, you know, if we just filled this up straight with 5, items 1, 2, 3, 4, and 5, if we took them off, we'd get 5, 4, 3, 2, 1. So this order looks a little strange, but that's because the stack wasn't empty before we started adding new things to it, which is very plausible. What's an example of a stack in real life? Well, whenever we're typing in something like Word, it's keeping track of our keystrokes, the data that we enter. So if you type, who's a good, each one of these is being added on to some kind of stack structure. And then you type boy, you type question mark, and you go, I don't know, what if they're a girl? So you hit Control Z, that gets popped off the stack, it backs the cursor up. You hit Control Z again, that pops off the stack, and you type good girl. That gets put on the stack. You tack on an exclamation mark. Then you decide that if you don't know that whether the dog's a good girl or a good boy, you should just say doggy. So you hit undo 2 times, that removes that removes that one, moves the cursor back here, and replace that with doggy. You get the idea. Your undo list is a stack, essentially, and so is your redo list. As you pop things off the undo list, they are added to a redo list so that you can redo them. Shift undo or whatever the keystroke is in Word. That's the idea of a stack. Stack's great. And you don't use it that much in large. Well, I'll just say this. You may run into times when you need to use it. However, and it's used inside your programming language all the time. Each time you call a method, it creates a new stack entry with all your data in it. And then you call another method, and all your local variables are declared on a new place in the stack. You call another method, all those local variables are created on the stack. And then you hit a return statement, all those local variables are destroyed. You hit another return statement, all those local variables are destroyed. So stacks are real important for certain applications of programming, but they kind of stink for others. What if you had a printer? Joe adds a printer document. I want to print something. Brad adds something to the stack to be printed. They're both waiting for it for some reason. And then Lori comes along, sticks her 500-page thesis on here. Brad and Joe are going to have to wait a long time before they get to print because it's first in, last out, or last in, first out, however you want to say it, LIFO or FILO. They mean the same thing. Lori was the last one to put it in, so she's going to be the first one to get her job printed. A stack would be a terrible implementation for a printer. Instead, you talk about the printer queue. And in England, they talk about queuing online, I mean, not online, but in line, like to go to a movie. And we stood on queue. Well, we don't use that word in English very much. We usually say we stood in line. But, when you're standing in line, the first person in line gets to go in. So Joe, Brad, Lori all submit their documents. Joe's going to be the first one to be printed. Yay. Brad's going to be the second. Lori's going to be the third. They're served in the order. So a stack is LIFO, last in, first out, whereas a queue is first in, first out. There are structures. There are data structures. There are classes within Java for handling this. However, you can also simulate it with a simple array list. Let's think about what is happening with a stack. And a stack, we push things on, we push things on, we push things on, and then we pop things off, we pop things off, we pop things off. All the insertions or adds, all the adds and removes are done from the same end on a stack. On a queue, if I could spell, then all the adds are done on one end and all the removes are done on the other. You add that, you add that, you add that, you add that. Each time you do it, you're pinning it to one side, but then you're taking them off the other to service them. So in a stack, adds and removes happen on the same side. And in a queue, adds and removes happen on opposite sides. I think we'll play with creating stacks with array lists today. But I also want to talk about how to reverse an array list. Two ways, and one is the same way that would work with an array. Did we do an assignment where we did a reverse of an array? No? Okay. No problemo.
But of an array, I think so, but not an array list.
Okay. Well, the concept is very similar. That's one way to do it, but it's not the only way. How you do it, regardless of whether it's an array or array list, is you swap these two items using a temporary variable. Then you swap these two items using a temporary variable. Let's pretend we've got two items there. And we swap those two items. So we have some counter, I, and then this is length right here. So this is length minus 1 minus I. Right there is that element. And then when I becomes, when I is 0, then length minus 1 is the item that we swap with. When I becomes 1, then length minus 2 is the item that we swap with. And that works regardless of whether you're using arrays or array lists. You just do something like this. T is equal to get, T1 is equal to get at element I T2 is equal to get at element length -1 minus I, and then T1 dot set the value of T2, and T2 dot set with the value of T1. I'm not sure that's exactly how we coded it, but that's the algorithm. And you only need to go up to halfway through the list, because by the time you serviced, you know, that many of them, you don't need to keep trying to swap them. In fact, it'll probably malfunction, and you may get the same order that you were presented with if you go out all the way to length rather than length divided by 2. That's one way. But with an array list, you can do inserts. It's hard to do inserts into an array. If you have an array of 5 items, well, say you declare 5, and then you put something there, you put Joe there. Then you decide that you want to insert Brad into the beginning of the array. You have to copy Joe there to make room for Brad. Then you decide you want to insert Lori into the beginning of the list. You have to copy all these values down by 1 to make room for Lori. Then you want to add Miranda. You got to move them all down again. Inserts are really annoying in arrays. They're really easy with array lists. You just use the .add method, but you specify the new index value, which is 0. That would insert into the beginning of the array list each time. So in general, the problem with arrays is that they are fixed length. Handling insertions and deletions into the middle of it require a lot of manipulation. What if you had an array that was 10,000 elements long, and you wanted to delete element 5? Then you would have to move up the other 9,900 whatever in order to fill that space. That would be 9,900 whatever memory accesses, you know, in order to get that to work. That would be very slow. Whereas with an array list, you can do a dot remove, and it will just delete that one item. So I believe array lists are actually in the next chapter, chapter 10, not chapter 9. Do we have PowerPoints for 10? We have not been moving the PowerPoints into the correct place. So the array list class, we saw how to instantiate an array list. Well, you just have to be psychic. Thank you. Guess we could down select. All right. So allocating an array list, you just use that word. If you have to add import java dot whatever it is, util dot array list up at the top, or you cheat and let Eclipse or NetBeans do it. Then in here, this has to be the name of the class. It can't be a primitive data type like int lowercase I or double lowercase d. It can be string with an uppercase S because a string is a class. It's not a primitive data type. And then students or whatever your array list is called equals new array list. Then to add to it, you use .add. So, make a new project. make a new project. There we go. Alrighty. Array list AL. So go to new array list. Except I forgot to specify the type. May as well make this an array list of strings. So array list, angle brace, string, angle brace, list name, variable, is equal to new array list. You don't have to put anything inside the diamond there. It doesn't know what an array list is, so we could go and add the import by hand, or we could do add import for java.util.arraylist. All right, let's append 3 items to the end of the list. So al.add and al.add Bob, al.add Chris. Now let's insert 3 items into the beginning of the list. You still use .add, you just specify the index value. al.add 0, Doug. al.add 0, Eric. And al.add 0, Frankie. Now let's print the list. For each string s colon in the array list, system.out.print line s. Bless you. So we run it. Key last. U2. U3. Really? Really? Alrighty. You run it and it says Frankie, Eric, Doug, and Bob, Chris. The reason it's in that funny order is we appended and Bob and Chris, but then we started inserting values into the beginning. Doug, Eric, Frankie. So let's write some functions that will do a push onto a fake stack that we're going to make. It won't be a fake once we're done with it. And we'll pop from it. And as we said here, if you're using a stack, you're doing your insertions and your removes from the same end. So let's actually play with encapsulation. We haven't done much of that. We've been avoiding the idea of making our own classes, but we can do this. Go over here to projects, or however you're going to make your new Java file. Right-click on the source folder, do new Java class, and just call it my stack. In acknowledgement that we're not using the stack class that's part of the Java distribution. It's going to be a stack full of strings, so we need an array list of strings to play with. Let's make it private so that the only way to add or remove data from it is through our methods. Array list string, we're just going to call it st for stack, is equal to new array list. So as soon as they create a myStack object, it will initialize, it will create and it will declare and allocate an array list. Again, I have to do the add import for java.util.arraylist. We want two methods. We want a .push method that will append something to the stack, and we want or to the beginning. We can pick which end we want to deal with, and we want a .pop, which will remove that item from the stack. So .push doesn't need to return anything. It can be void. But pop needs to return a string. Let's just declare those before we code them. Private void push takes a string. And then private void pop, it's not void because it's actually going to return a string. So private string pop, but it doesn't take any parameters. We're not passing any data in, we're trying to get data out of it. And for now, I'm just going to add return null, just so that it'll compile, if I ever tried to. Okay, so we need to pick an end. I'm not sure which end you'll think would be easier to manipulate on our array list to simulate our stack. Do we want to add and remove everything from the beginning of the list at item 0? Or do we want to add and remove everything from the end of the list? I have an opinion. Anybody else care? It doesn't really matter. The only reason I'm going to say do it from the beginning of the list is that if we do things from the end of the list, occasionally we'll have to manipulate, the item number. We'll have to use the list, the length of the list -1 or whatever, and it's just easier to always specify 0. Okay, so when we push something, we have a piece of data that we want to add to our list, so we're going to insert it. How do we insert something into the beginning of our list? st.add. Then what do we do here between the parentheses in order to insert it rather than do an append?
0, comma.
Yeah, 0, comma, and the string that we're passing in. I guess we could be awesome and print a message saying pushed plus the string. Kind of a debug message. Now popping is a little bit more complicated. Why? Because what happens if you pop and the stack is empty? We can't just willy-nilly going and try accessing element 0 if it doesn't exist. So we're going to have to check to see if the array list is empty, and if it is, then bail out as soon as possible so we don't mess anything up. So if stack dot, we could either do is empty or dot size equals 0. I think I'll do dot size equals 0. Dot size parentheses in parentheses is equal to 0. Just return a null. Return nothing. We could return an empty string, but let's just return a null. Now, if that's not the case, then we're going to get the first element out, and then we're going to remove it. So string s, how do we get the first element out of the stack? We use .add to put data in. How do we get data back out? Notice I keep using the word get. We use the .get method, and we specify the index value. So since we've been inserting into the beginning of the list, and a stack requires us to add and remove data from the same side, we're going to get our data from the beginning of the list. Once we've got it, we need to delete it. It's no longer supposed to be in the stack. So st.remove that element, and then return s. All right, we have our stack class. May even work. There's some other stuff we probably ought to add to it. There's a whole bunch of stuff you could add to it, but the idea is just to burn into our brains what the stack is. Let's go back to our main method and use that class. So back over here, we're going to declare an object of my stack. My stack, I'm just going to call it my, is equal to new my stack capitalization has to all be correct. We didn't need any of this diamond business, the greater and less than stuff, because that's all encapsulated inside the MyStack class. Now let's push 3 items onto the stack. My.push. Let's see, we were up to F, G, George. My.push, H, Howie. I'm getting errors. Probably because I forgot to make those methods public. Yep. Go back to the MyStack class and make the push and the pop methods public. Don't know what I was thinking. That ought to work. My.push, H. Give me a name that starts with I.
Ida.
Ida. Ida, no. There we go. Now let's pop those 3 things. Let's just declare 3 strings. N1, N2, N3. N1 is equal to my.pop. N2 is equal to my.pop. N3 is equal to my.pop. Then let's print them out. System.out.println N1 plus a space plus N2 plus a space plus N3. And then just for giggles, I'm going to do N4 is equal to my.pop. And print it out. That should say null. We didn't have any data. Oh, I forgot to declare string N4. So in front of N4 equals my.pop, string N4. All right, hopefully it will print these names in the opposite order in which they were inserted. George, Howie, and Ida. So we pushed George, we pushed Howie, we pushed Ida, but then we popped them off. We got Ida, Howie, and George. Now I put debug print statements in the push, and I forgot to put the debug print statements in the pop, but that's okay. We really don't want debug print statements in our finished code anyway, so we'd go and comment it out. Now what would it take to turn that stack class into a queue class? What did we say the difference was in the way they worked fundamentally? One did its insertion and deletions on the same side. The other did what?
Did it on the opposite.
Right. And so since our pop is getting element 0 every time, our push doesn't do an insert, it does an append. I don't think we really need to do that. When you're doing work with a queue, you don't use the word push and pop. Some people use the words NQ and DQ. But that's the idea behind a stack. That's the idea behind a queue. Anybody need any help fixing typos? You're good, Miranda? Was that a no? Maybe. Let's come look.
I've got it written down.
So we talked about single-dimensional arrays. How much did we talk about two-dimensional arrays? We broached them. We're masters of them.
I don't remember. It's been a rough week, so I don't have any answers.
No idea what it is.
Pardon me?
No idea what it is.
All right. Then it's time to talk about it. But we have talked about partially filled arrays.
Yeah.
Yes. Like you're printing it, I'll say.
So a two-dimensional array is a table. It's a grid, like when you use Excel. You have rows and you have columns. So instead of accessing them just with one index number, you access them with two index numbers. So if the array is named X, that element is called 0, 0. That element is called 0, 1. That element is called 0, 2. That's 1, 0, 1, 1, 1, 2. Here's how you allocate a two-dimensional array. It's one way. Let's just make an array. Oops, I almost started to make an array list. That's not what I want. Let's make an array of ints, but it's going to be a two-dimensional array, so we need pairs of square braces. I'm just going to call it IA for int array. Is equal to new int. Let's make it a 3x3 array, like a tic-tac-toe board. Now we need to print it out. Printing with for each loops is always easier than printing with for loops. But let's go ahead and do for loops first. For int row is equal to 0, row is less than the length of the array, ia.length, row plus plus. I switched from row to R, excuse me. Type the whole word. Now we need a nested loop. Why? Because the row counter indicates which row we're on. The column counter indicates which column inside that row. So we're going to use another loop inside there for column is equal to 0. Column is less than IA. Now here we can't use dot length. The reason why is because there's no guarantee that the number of rows in the columns are going to be the same. It could be, but we could have 3 rows with 100 columns. So instead we need to ask that particular row what its length is. So IA square braces row dot length column plus plus. Then we need to print that value, system.out.print. I'm going to use printf because it helps the spacings evenly out. Why not let each int occupy 5 columns? So %5d, comma, and now here we specify our value, IA, subscript, row, or inside braces, row, and then inside braces, column. This inner loop is going to print every item in the row. But when we get to the end of the row, we need to hit return on our typewriter, so we need to do a system.out.print line here. All right, that'll print out our array. It's not going to be a very interesting array. It's all zeros. So let's take some notes about what we've done so far. A stack is LIFO, which means what?
Last and first out.
Right. You push to put data in. You what to get data out?
Pop.
Pop. If you do a pop when there is no data, it will generate an exception. Not our version, but the official version. When you pop, it actually removes the item. But there's another command that we didn't implement called peek. Peek will examine but not remove that item. So the keywords to remember are push, pop, and peek. Now we didn't talk very much about a queue, but we'll say that a queue is FIFO, first in, first out. Add data to one side, one end, remove it from the other. A think I forgot to mention that about stacks. Data is added and removed from the same side for stacks. Put data in, you do NQ. To remove data, you use DQ. My guess is that there's a peek command as well. Alrighty. Stacks and queues are not mentioned in the book. I'll give a PowerPoint. You're also very, very encouraged just to go and read about them online. When you declare a three-dimensional array, a two-dimensional array, you don't have to allocate it like that. You can also use an initializer list. That would look something like this. Int, let's make an array of doubles. So, we're going to leave it an array of lists, but we're going to call it IA2. How about that for a creative name? Is equal to, and just like we did with the other list, we used initializer list, right? Stuff like that. We've seen that syntax. We can specify rows and columns. So inside this pair of braces, I'm going to tack on some rows. Let's do 8. My favorite numbers. 8, 6, 7 are in the first row. 5, 3, 0. In the second row, I forgot to put commas at the end of these rows. I'm going to have to go back and fix that. 9, and then I'm done with my phone number, so I'm just going to tack on some zeros at the end. Now I needed a comma here, at the end of that one, and here. Forgot those. That's why I'm getting the red underlines. Do I need it spaced out the way it is? No. Could I do all this on one line? Yeah, sure. But I'm spacing it out like this to make it clear what a two-dimensional array is. As far as Java is concerned, it's an array of arrays. When we did an initializer for a one-dimensional array, we just did some items separated by commas. Here, the items separated by commas are their own arrays. So that lets us know that we could iterate through a two-dimensional array with 4 each rather than with 4. So for every row, and a row is a single-dimensional array. So for every int, I don't want to call it row because we use that name up here. So I'm going to call it R row array. How about that? Not really digging that. I should have just called it row. RA. How about that? In our array. And then for every int in that row, I'm going to use E for element. Print that out. System.out.printf, same kind of business. %5d. But we don't have index numbers at this point. We just have an element to print out. So I'm not going to use IA sub row sub column or anything like that. I'm just going to print out E. At the end of that row, I need to print out a character term. Hit the return key on our typewriter. All right, there we have our 2 arrays. So go back up to this one that was a 3 by 3 and make it a 10 by 10 instead. Not the one where we initialized it, but the one where we had a blank array. And what I want you to do is to make it I guess I could have left it 3 by 3, but I want you to modify it in such a way that you don't have to add this comment. I want this item set to a 1. I want this item set to a 2. And this item set to a 3, assuming that this is the very corner of the array, that's 0, 0. Let's go ahead and run it now that we've changed it to 10 by 10 just to make sure that we get a 10 by 10 array. Yay. So I want that one to be a 1, I want that one to be a 2, and I want that one to be a 3. How do I do that? What do I add to this code right here to get that to happen? Well, I don't need a query for input. I'm just going to force this item to be a 1. What's the position of that one?
0, 0.
Yeah, it's 0, 0. So IA 0, 0 is equal to 1. What is the position of that one? Which row is it on? It's on row
That's
1,
row 1, column 2.
column 2. So IA 1, 2 is equal to 2. So what are the coordinates for that 3?
2, 1.
Yep, row 2, column 1. And there we go. We have a 1, 2, and 3. Let's write 2 bits of code. One that is going to wipe the array out and set it all equal to zeros. Now we could just reallocate it, that'd be the fastest. But let's use for loops to reset all elements. Zero's boring. Let's change them all to 1. And then, I should have said loops. After we print it out, use for loops to assign random values between 1 and 9999 to each element. I didn't specify which array. Let's use our 10 by 10 array. It's more interesting. Then we want to print it out again. To get the random values, we're going to use a random class. But firstly, let's just reset everything to 1. So we're not going to use for each. Why? Because that doesn't let us change the values. We're going to use for. I'm tired of typing the whole word row and column, so I'm going to get even lazier and just make it R and C. R is 0, R is less than IA.length, R++, for int column is equal to 0, column is less than IA. Nope. I can't get the length of the array as a whole because it's possible they won't match. What do I do to get the length of just this row that we're on?
Put R in boxes.
Yep. Put subscript R dot length.
So that's supposed to be a for loop?
Yes, that was supposed to be a for loop. My apologies.
It's cool.
For int c is equal to 0. C is less than IA sub R dot length. And then C++. I don't know why I was trying to increment R there. Then we want to change that value. IA box R box C is equal to 1. We're not printing anything. Now writing this print code is getting tedious. We could make it a method. Let's Let's write it once and then maybe turn it into a method. Nah. So, but let's use for each because the syntax is easiest. So for int array, RA, for the row array, in IA, then for every element, int E colon, in the row array, print that out, system.out.println, not println, printf, %5d, end quote, comma, that element. And after that, print a blank line. You're using Eclipse, right?
Yes.
How do you highlight a chunk of code and then say, I want to automatically turn that into a method? Can you do that in Eclipse?
Method, I'm not sure.
All right. We want to make this a method. We're getting really tired of writing it. So, after we do the randomizing, let's make sure this worked though. Then we're going to convert that code to a method.
Yeah.
There we go. We got a stack of 10 by 10 ones. Something to notice about arrays, and I'll scroll back down if you need it, is that they don't all have to be the same length, each row. This one could have just had 2 in it. This one could have had 20, and this one could have had 3. That's what's known as a ragged array. Some texts call it a jagged array. It's not just a simple rectangle. Your for loops handle that. If they are not hard coded to a number like 10 or 3 or something like that. If you ask the array how long it is, or you use a for each loop, it handles that. Now the concept of ragged arrays is kind of weird. When you're making tables in Excel, you usually don't have one row with a lot more items on it than the next one, in my opinion. All right. We want to fill it full of random data. We're going to need the random class. So random, R&D, is equal to new random, capital R's. And we need the import for that. Add import java.util.random. Oh, wow. Are we out of time? Are we out of time? We're out of time. But we can do this real fast. For int r is equal to 0 colon. R is less than the length of the array, ia.length, r++. A nested loop for int c is equal to 0, c is less than ia box r dot length. I like that box nomenclature. I'm going to use that from now on. Oh, I forgot my semicolon C++ there. And then IA sub r, box C is equal to R&D dot next int, but we want to give it an upper bound, 10,000. So it'll be from 0 up to 9999. So 4 zeros. And why don't we just hold it there? Because we really are running out of time, and you may need to run to your next class, and I know I need to. Just copy that print code from here and paste it here. And we'll see if we got our random data. Yep.
Sure didn't go for the small ones.
Pardon me?
It didn't go for any single digits.
No, it didn't. I got some in the hundreds.
Oh, I take that back. I got one in 15.
Oh, you got down to double digits. Okay. All right, that's enough. Let's make a Dropbox for this.
Wait, no, there's
steal this print code from here.
Realize that mine's in
Oops, paste it there.
That's as small as it gets. That's 2 digits.
and one.
I got one.
You
No, I just built it.
got four.
And there we go.
I remember.
First try. Great. You got a 4 in there. Look at that. How big, how many times would you have to run this in order to get the number 0 generated? Or the number 1? Any specific number? I don't really know. It's 100 elements. I'm sure statistically there's a way to calculate that. How many times you'd have to run it in order to have a 50% chance of getting that value? I don't know. All right, I didn't cook up a homework assignment yet, so finish the one that you've already got assigned if you haven't. And we'll meet again on Monday.
I may be a little late, but I'm gonna try not to be,
Okay.
so.
That's not fair. I'm allowed to take time off and you're not.
Well, I'm taking time off from work so I can go visit my folks in Colorado.
Yeah.
So, driving back on Monday.